Hello everyone, it's time for another Leetcode problem. You are given a string S consisting of the characters A, B and C and a non-negative integer k. Each minute you may take either the leftmost character of S or the rightmost character of S. Return the minimum number of minutes needed for you to take at least k of each character, or return -1 if it is not possible to take k of each character. So what it means is that you have to return the minimum number of characters that you should take from left side and right side, so that the frequency of each character is greater than or equals to k, or is at least k. So for example, let's consider this example: AAB 4 times A, C 2 times A, B and C, and k equals to 2. So we need to find the minimum number of characters that we should take from left and right, so that we have at least k of each character. Okay, so let's say we take one we take one from here. So we have one character from left, so now we have A1, and we take 3 characters from here, right? So now we have A2, B1 and C1, but we need 2 of each. So okay, so we need 2 of each. So what can we do? Can we take more than it? So let's say we take 3 from here and we take 5 from right. So 3 characters from left and 5 characters from right. And how many? So now we have A 4, B 2 and C 2. So now we have at least k of each character. And how many characters did we take? We take 3 from left and 5 from right. So total of 8 characters. And this would be the minimum. You can try all other combinations and you would find this is the minimum number of characters. Now how to approach this problem? So we have two things. We can take characters from the left side and characters from the right side, and we can't take any character from in between. Okay, and what do you want to do? We want to maintain frequency of each character A, frequency of B and frequency of C. It should be at least k, and we need to return the minimum number of characters that we should take. Okay, so now how can we approach this problem, or how can we think towards developing an algorithm which would give us the solution for this problem? So why don't we do one thing? We need to take characters from left or right. So let's say from left we are taking x numbers of character. Suppose from the left we are taking x numbers of characters, then how many characters do we need from the right to satisfy the constraints? For example, in this example, let's say from the left we are taking 2 characters. So if we take from the left, if we are taking 2 characters, let's call this left and let's call this right. So now we have numbers of A is 2, but we don't have any B, we don't have any C. Now how many characters do we need to take from the right to satisfy the constraint, that is we need to have at least k of each character? Okay, so let's say we take only one from right, then we would have C1. So now we have a total of, let's say total, So we have total of A2, total of B0, total of C1. So that means we need to take more characters from right. If we take 2 characters from right, then B would be 1. Okay, and now we need to take more characters from right. So if we take again, then we would have more quantity of A. So for A this condition is satisfied, but for B and C it is still not satisfied. So we will take more characters from right. Now A is 4. Okay, now we take more characters from right. So now C is 2. So now for C also this condition is satisfied, and we need at least 2 B's. So that means we have to take all till here, because this is the only B we have. So after taking all of these characters from the right, we would have like how many characters? So we would have C2 and A 1 2 3 4 5 6. So we would have 6 A's, we would have 2 C's, and we would have 2 B's, and so we would have a total of these numbers of character A1 B2 C2. And now for all these characters the constraint is satisfied. So that means if we take 2 characters from the left, then we need to take how many characters from the right? We need to take 6 4 10. So we need to take 10 characters from the right. And so how many characters did we take in total? We take 12 characters in total. Why? Because we take 2 characters from the left and 10 characters from the right to satisfy the constraints. Cool. But will this help us in developing the problem? Let's see. If we take x numbers of characters, then we have to take 10 characters from the right. What if we take x plus 1 characters from the left? If we take x plus 1 characters from the left, then we would be having what? We would be having A equals to 2, B equals to 1, and C equals to 0. And now how many characters do we need to take from the right? So again we would do the very same thing. We would go each character one by one from the right until this constraint is satisfied. Okay, but isn't it the repetitive work? For x we did the same thing, and now for right we are also, for x plus 1 we are also doing the same thing. So is it a way to determine this from the previous approach? If we are able to determine this, can we determine it? Let's see. Okay, so in the previous approach we were taking this menus of character. Okay, so that means we would have A6, B2, and C2. Now what just happened? If we increase the number of characters by 1 from the left, that means we are adding only a single B from here to here. That is, only B is incremented by 1, nothing else is changing. Okay, so what does that mean? Let me bring this down first. Okay, so what does this mean now? Earlier our left was here, so earlier our left was here and our right was here. Now we have incremented our left. Let's say left is here, so that means now we have more quantities of B. So that means we can reduce at least one B from here. That means we can move this R to here. Okay, so in that case from the right we would have A6, B1, and C would still be 2. So is this still satisfied? Are our constraints still satisfied? Yes. Okay, but can we do something more here? Now if you see, we have more quantities of A than we need. For B and C it is satisfied and R is pointing to A. That means we can still reduce this R. Okay, and how can we reduce? How many A's can we reduce? We can reduce all the 4 A's. That means our R can point here. So now we have only 2 R's here. Sorry, now we have only 2 A's in the right, and still our constraint is satisfied. Now the right is pointing to C. Okay, now can we reduce this R more? No, why? Because if we reduce this r to here, in the right c would be 1 and these conditions will be violated. So we can't reduce this more. That means our r will point here and we would have to take 5 characters from the right. So that means if we take x plus 1, that is if we take 3 characters from the left, we need to take 5 characters from the right, the minimum of 5 characters from the right to satisfy these constraints. And the magical point is we don't have to calculate it from the right again. We just used our previous solution and modified it or updated it to get the solution for this problem. Now, is this approach hinting you something? Is this approach hinting you towards the algorithm? Let's see. So what did we do? First we take 2 characters from the left and find the number of characters that we needed to take from right, that is 10. Now we increased the number of characters that we were taking from the left by 1, and if we found that if we take 3 characters from the left, the minimum characters that we needed to take from the right is 5. Okay, so now the algorithm is pretty simple. Let's say initially we take 0 characters from the left, then we would find how many characters we need from the right. Let's say this comes out to be x. We need x characters from the right. Okay, now what we would do, we would just increase the number of characters that we are taking from the left. So now we would calculate, if we take 1 characters from the left, then how many characters do we need from the right. Then we would do, if we take 2 characters from the left, then how many characters we need from the right, and we would do up to all the characters. So we would, let's say our string says 5 characters. So initially we found for 0, if we take 0 characters from the left, and now we would do for 1 characters from the left, for 2 characters from the left, for 3 characters from the left, for 4 characters from the left, and for 5 characters from the left. And whatever gives us the minimum answer, that would be our answer. Okay, so this is the approach that we are gonna follow. Okay. Yeah, I think that's all that we have to do in this problem. But let's see, we also have to return -1 if it's not possible. So how would we do it in the algorithm? So just like this, we would make 2 maps. Let's discuss the algorithm. So initially when we are taking 0 characters from the left, so we have this string s equals to AAB AAA AC AABC. So initially we will declare 2 maps, left and right. And what we do, we would make 2 more pointers, left equals to 0. Let's say initially we just have to take r equals to 0, sorry, r equals to n-1. So initially we are taking, so initially what we are finding, if we take 0 characters from the left, then how many characters do we need to take from the right. So we would iterate backwards from the right, and we would find the minimum number of characters such that the constants is satisfied, that is each character should be at least 2, k equals to 2. Okay, so we would point out r2 here. Let's say this is 0 1 2 3 4 5 6 7 8 9 10 and 11, and we would need to take the characters up till here. That is, if we take this, then a would be 6, b would be 2, c would be 2, and this condition would be satisfied. So our r would be pointing here at the end. So our r is pointing to 2. Now how can we find how many characters do we need from this? It is just nothing but what? Just n minus r, because n is 12 and r is pointing to 2, so it will give us 10. And how many characters are we taking? 1 2 3 4 5 6 7 8 9 10 10. So initially we can find that if we take 0 characters from the left, then the characters we need to take from the right is n minus r. So we'll initialize our answer to n minus r. Now we would start taking characters from the left and we would try to move the algorithm. Okay, so initially our answer would be n minus r, which is just 10. Now we would do L equals to 0, that is we are taking one character from here, L. Now if we take, then we would have A equals to 1, we would have B equals to 2, and we would have C equals to 2. Okay, now how can we update the algorithm? Whatever we discuss here, how can we implement it in the algorithm? Okay, so now let's see, we have to satisfy this condition that left of A, since our r is pointing to B, that means if we move r towards the right, then this map will change. So that means what we have to do, if we are moving r, we have to ensure that left of SR plus right of SR, this is still greater than equals to K. If you move r and this violates, then that means our constraints will not be satisfied. So if we are moving, we have to ensure this holds. And why we are doing S of r? Because since we are updating r, so that would be the characters whose frequency would be changed. Okay, so now if we see, initially we would have 0 of this, so our r is here. Now if we are here and if we move r, so what will happen? So left of it is 0, right of it is 2, so it is greater than equals to K. Okay, but if we move this, so will it happen? So no, it is exactly K. 0 plus 2 equals 0 plus 2 equals 2, so this is exactly K. So that means we can't move this, because if we move the r, then this would be less than K. So that means we can only update the r if this condition holds, greater than K. Okay, so we will check if left of SR plus right of SR is greater than K, then move the right pointer. Other case would be what? Okay, so we move it here. Now let's say when L was here, so we would have two A's. Okay, not here. Let's say when L was here, and when L was here, and let's say when R is here, so we would have two A's, one B, and we would have one B here. This would be the configuration. Okay, now in this configuration, if we look, our R is A, so this condition is true. Left of SR, our left of SR is already greater than equals to K. That means we need to take 0 characters. So if left of SR is greater than equals to K, then that means we need 0 characters of SR. Our SR is A, so that means we don't need any A characters in the line. So in this case, if left of SR is greater than equals to K, then we can freely move the right pointers, because we already have 2 characters of A in the left and we need only 2 characters in the left. So our updated condition is, we will do while r is less than n and left of SR, if this is greater than equals to K, or if right of SR plus left of SR, if this is greater than K, then we would move our right pointer. So first we would update this frequency. So we do right of SR minus minus, and then we would update our right pointer, and in each step we would have to update our answer. So answer would be minimum of answer, comma. Now the characters that we're taking from the right is n minus r, but how many characters we're taking from the left? So let's say L is pointing here, so L is 2, but how many characters are these? These are 3 characters. So that means if L equals to 2, then the number of characters that we're taking from the left is L plus 1. So total number of characters that we're taking is n minus r plus L plus 1. And at the end of the algorithm, we would just return this. Okay, so let's look at the code. So we we created two maps, left and right, and if k equals to 0, then our answer would simply be 0. And now we are finding, if we take 0 characters from the left, then how many characters do we need from the right. And let's say our k is 2, but we don't have sufficient, and in the string that we have only, let's say, a1. Let's say our string is this abc, and k equals to 2, so we need 2 characters of each, but we would not have in that. But in this case we don't have 2 characters of anything, so in this case we have to return -1. And when will this be hold? Since we are counting all of the characters, if r reaches -1, then that means there are not sufficient number of characters, so in this case we would return -1. Now we would try to find answers by taking 0 number of characters from the left, then 1, then 2, then 3, up till n. So first we are incrementing the characters, updating the frequency of the characters in the left, and now we are checking this. If left have if the number of characters is sufficient in the left, or if the left plus right is greater than k, then we would update it. So we would move our right pointer and we would update its frequency, and answer would be minimum of answer comma l plus 1 plus n minus r. L plus 1 is the number of characters that we need to take from the left, and n minus r is the number of characters that we are taking from the right. And finally we will return our answer.